Hello everybody and welcome back to the DCAC channel, where in this series we solve technical interview questions just to prepare, and yeah, I hope you learn with that. So let's pick another question for today. Island perimeter. Let's see what that's about. So 463 island perimeter. All right. You are given a map in form of a two-dimensional integer grid, where 1 represents land and 0 represents water. Okay? Grid cells are connected horizontally or vertically, not diagonally. So basically either like this or like this. Okay. The grid is completely surrounded by water, and there is exactly one island, i.e. one or more connected land cells. Okay. The island does not have lakes, water inside that isn't connected to the water around the island. Okay. One cell is a square with side length of 1. The grid is rectangular. Okay. With a height, width and height don't exceed 100. Determine the perimeter of the island. So the perimeter would be, I guess, counting all the sides that are not connected by land, right? Like this side is connected by land. We see that, at least in the picture, right? We have to kind of represent that in our code now. Let's see. We have this guy here, right? And the output should be 16. Explanation. The perimeter is the 16 yellow stripes in the image below. So basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We know that each piece of land is connected to at least one more piece of land, right? Which means that for each of those thingies here, we get a maximum of 3 to like a 3 added value to the output. For example, if we had this guy, this guy, this guy, and this guy, and everything else was water, actually that's not even the so everything that's not on the edge will always be connected at least between yeah right, because I think we'll have to actually bust out the old paint here and let's see, let's have something bigger. So if we have one square and another one, right, they have to basically touch for them to be considered part of the island, and we know they always touch at least one more square. So basically each square touches at least one more. You can already see the maximum value of not touching sides is 3 for each of them, right? But this second one, given that it is somewhere in the middle and not standing on the edge of the map, it will also touch another one, at least at least another one, either here or maybe here, you see? So in this case, like, we can actually even ignore this one for now, just to was it like this? Was it like this? Yeah. Just to kind of see that it's irrelevant from which side we look at it. Each actually I want to see the grid. So the grid would be basically, okay, it will go like this. Now, what we actually also have to think about in this case, okay, we can actually have a strategy, because we already kind of broke down some of the rules that govern the amount of sides that we get. All right, everything that is not touching the side here would have at most 2 other sides that are free, right? Like in this example that you see here, you can see this guy is not touching the edge, so it has at most 2 free sides. Now I don't know if that would help us I guess how we could actually think about this problem is just going by the ones and zeros here. We still can apply some of the rules that we already seen. So that's an interesting question. I think I've kind of went to a solution that I've seen in a video before. It's not exactly this problem, but it was something similar, and that's how you actually recognize it's a useful thing, because a lot of these patterns emerge in multiple questions. I mean, like the way to solve them, and that's something that you kind of have to practice for the really tough questions when it comes to Google interview questions. So what they did was what I also kind of do. We will go for a row in actually I'll also do index row in grid and enumerate grid, and you will see what I mean. Here we will have our map. We shouldn't call it map, we would call it island coordinates, and this will be empty for now. What we want to do here, we go over each of those indices and rows here, right? And what we do is we also say for each index column. Oh yeah, never mind, just forget my stupidity. So we are doing this, we are going for each of those rows, and then we are saying for each index column and column, or even just like cell, and we are just enumerating the rows now, right? Because we actually started by going over these, and for each of these we also want to go inside of them and enumerate here, and we actually want to know the row index, the column index, and the value would be cell. What we do now is we say island coordinates, and we now pack basically the coordinates where we are at now. They would be basically index row, index column, and we pack the cell value. So what this does is basically just runs through the whole map and packs everything inside. I actually had it before as a small example of what I meant. Something like this. It will go over, for example, 0, 0. It will look, okay, it's a 0. It will go to 0, 1. Let's say this is 0, 1. It will see it's a 1. Okay, it will put a 1 here, and then later we can actually retrieve that data. And what this data will help us achieve now is that now we can say for land in island coordinates, how is it, values? Actually no, we want key and value. Land, this would be coordinates, and yeah, land would be 1, 0 would be basically water, right? Let's have it like this. Was it items? I think it was items. We'll have to see afterwards. We'll have to debug it. So now we have all those coordinates packed here, right? Zeros and ones for all the coordinates. Now we can go and we can take this thing, and now what we do is basically we know that the maximum would be 3 for something that's not being touched by anything and it's on the corner. And well, let's have our out ready as well. Out would be 0 at the beginning, although it's not really, but let's have it like that. And now what we want to do is, how do we do it? We have coordinates, we have land. We say out would be increased by the amount of 3 minus, so we know 3 would be the maximum. And now we say, okay, we have the coordinates here, right? Actually it would be 3 times land. So if land is a 0, we'll get a 0 automatically, so we will not really increment anything here. And I write this in this way, so it's kind of like, it's a one-line solution, it's kind of like a formula. You can always have it, if this is 0, skip, and blah, blah, blah. I guess it would make it faster, but I'm kind of thinking in this direction right now, just to kind of simplify some of the stuff. So we have this, and what we want to know is actually, okay, the maximum is 3, but maybe it's touching something, right? So how do we simulate if our piece of land is touching another piece of land? What we want to do is basically island coordinates will get, and now we want to have, how do we do this? We know that coordinates is a tuple, right? And let's see, for example, I want 4 coordinates land in container items, print me coordinates. Why I want this? I want to see how I can actually access that. So can I do something like this? I want the second one. Yes, I can. So we want to get the coordinates that are one above a single piece of land, right? In this case, there would be nothing, but that's okay, because doing the get method, we can actually look, and for example, this would be one above would be, basically it would stay on the same row, on the same column, but it would be one row back, right? So it would be -1 on this one, and it would stay on the same one, right? It would be on the same vertical, but basically on the same horizontal, if you look at the row columns, but it would move one on the vertical, which would be the rows, so basically here. So if we are looking at, if you want to look at this one, like the cell above, it would be something like this, right? And if we do the get method for this container, and let's actually have it like this as an example. We'll have get, and what we want is we want container get this guy, and if you don't find it, just return me a 0 or something that we know it would be interesting, like for sure that we'll see. And yeah, we see this is not there, this coordinate is not there, we'll get a 5. What we want in our case is to get a 0 back. So and this will be here, we get the 0 back, so that we know if this doesn't exist, we also don't subtract, right? If it exists, we actually get the value from it. If the value is 1, it means that it's touching land, for example this one here, and if it's touching land, we can actually subtract 1 from that value that we're looking initially, right? So it was 3, we looked above, we cannot find this coordinate, we get a 0 back. We look right, we find the coordinate, it's a 0 though, we subtract 0, value stays 3. We look left, it's a 0, existing coordinate but 0, we subtract, we are still left with 3. We look 1 down, it's existing and it's a 1, so we subtract 1 and we get 2, right? And actually now I see now I see my problem. It's actually maximum 4, and you always subtract, and it will always subtract for those that are touching the corners, because they will also touch something inside the map. Something that's inside, for example, 4 minus 1, 3 minus 1, 2 minus 1, 0, 1 minus another 1, 0. So this one would actually net us 0 in our calculation, and that's what we want. So here is the only thing that we actually still are missing, and this would be coordinates
I'll pack it as a tuple, and the first would be coordinates, the first coordinate -1, and the second one would be exactly like that. So this is basically left. This is one above, right? One below would be the same but with plus. And I just want to kind of make sure we're not getting some because it's kind of getting technical here, but yeah, we do a tuple, and we are just using the value from these coordinates, subtracting one on this one, leaving this one the same. So the same thing, we can just continue. And like I said, that was the one above. The one below would have actually the next row. And we continue, and actually I'm already getting uncomfortable looking at it like this. So I just do it like that. The one on the right side would keep the same row, but it would increase. Well, actually, let's go to this one, the left. We decrease the columns, right? And we keep the rows. Exactly kind of the opposite of here in this case. And the last one, again, we keep the row, and we actually want to see one column to the right. So basically +1 on that. And this should be more or less everything that we had to do. And I'm not joking. Basically, we go over all the coordinates that we stored. Basically, we have coordinates 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3, you know, 2, 0, 2, 1, 2, 2, 2, 3, and so on. They go in a line. We just go over all of them. And for each of them, we just look at each side, and we subtract from the maximum that we can get. And it's just one single formula. And the only other thing we had to do is this mapping here. Now let's see if there is something wrong. Well, we got an output of 17 instead of 16. Now that's curious. Okay, so the issue was actually pretty stupid. I guess you have to break the line here, and I was also not indenting. But I'm wondering how did Python even run without breaking the line if it doesn't actually accept it as part of the same line? Like, anyway, I also added a statement that if the length is 0, we just continue, because otherwise we can get some weird issues that, for example, we get 0 minus something that has a 1, for example, here, and minus something here, and then we get -2 on this result, right? And we actually add it. And this would also make problems. So I actually skip all the 0 lengths, and we also only count the ones that actually are lengths. So the ones. So that means that we can actually go without this multiplication operation here, which should save us a bit more time as well. And yeah, the process is still the same, right? You only have to map your problem into a coordinate map, basically, and then you also only look at the coordinates up, down, left, and right. We subtract them from what you've seen the theoretical maximum would be 4, and that's all. Actually, a pretty easy question, and it's I think a very good starting level for all those types of questions that require you to have a hash map, in this case with coordinates, and then iterating over those coordinates and doing some advanced level stuff. And yeah, when it comes to our for example, time complexity, I would say this would be going once over the whole matrix. And the second part would be again going for each of the cells in the matrix, looking at 4 other operations plus this minus operation at the beginning, like 5 times the size of the matrix. So we are still looking at linear progression when it comes to runtime complexity. when it comes to space-time complexity, we would require a mapping that would basically have values for each of the elements in the matrix. So basically getting at least n space, and actually 2n, because yeah, you have the key and the value. And for this here is basically a single variable. So we are still looking at linear progression when it comes to space complexity. Not sure why this. Maybe somebody can educate me how to optimize it further. But for me, it was actually a pretty cool question. And I really like the fact that I can pack everything that comes to the decision logic into a single formula that would basically sort itself. I don't have to put multiple if-else statements, and then if you later have to work with that thing, then it's kind of confusing. You just get a single formula, and yeah. Anyway, I really like this question. I hope you also liked it and you learned a lot of new stuff. Definitely try working with dictionaries and hash maps basically, and putting tuples or I don't know, like other dictionaries inside of them, and trying to work with that. Very useful stuff, and I will see you next time. Bye bye.